We just mentioned this sequence number to acknowledgement indicate the sequence index of the frame, which is the last frame being received, right? So in other words, we can think this kind of, if I receive that package and send out this acknowledgement, that acknowledgement in this protocol consider is a cumulative. What means cumulative? Means this knowledge, this index will tell me all the package up to this package which associated with this acknowledgement has been received. For example, if I send this acknowledgement 5 or ACK5, that means all the package or all the frame up to 5 has been received. So that is why we call it accumulative. And then, and because of that, so basically I can always update this the quantitative information associated with the receiver, including LFR, LAF, and the receiver window size, W and RWS as following. As soon as I receive this sequence number to acknowledgement, I will update that or I will use that to update LFR because that'll tell me up to what kind of package already received. And then I can adjust LAF by calculating LFR plus RWF because RWS is predetermined, the window. Okay? So here, just to give you example, right? If I receive I know the information LFR is equal to 5. Basically, I received the ACK, that acknowledgement 5, right? Because it's cumulative. So I will using that value to update LFR, right? And then because I know the window size is 4, so I will know LAF is 5 plus 4 is equal to 9. So I think later we can see the example. Okay, we will see the example very soon. Okay. So basically, anytime you receive this index, you will know that value will be used to update the LFR because all the acknowledgement are accumulative, and then I will using this one continue to update LAF. So if you assume you have LFR equal to 5, so I know the window size is 4, I should be able to know LAF is equal to 9. Right? What means LFR equal to 5 means why I know that one, because I receive an acknowledgement tell me up to the package 5 I already received. So again, so just assume another situation, okay? So basically now, after I receive the package 5, or say the frame 5, I continue to receive the frame 7 and 8. What does that mean? That means potentially the frame 6 is either delayed or cropped, right? So in that case, the frame 7 and frame 8, although received by the receiver, but the receiver will not send acknowledgement because these two packages is out of order. Okay, so what they do is they buffer these two packages until they receive the package 6 or say frame 6. And then they will send out the acknowledgement frame 8. Okay, so basically, let me just get a pen. So basically assume, right? So I have, and this is the sender, right? Okay, so this is the receiver. And so what they do here is I will keep sending like 5, for example, up to 5, okay? So here I received the acknowledgement, right? AKC, sorry, AC. So the acknowledgement 5. Okay, so now I began to sending 6, but 6, let's assume 6 has an interruption or cropped. So then basically it does not reach this receiver. But what it received is frame 7, or you call it package 7, and package 8. So what the receiver do is, receiver will not send, because you remember this ACK is accumulative, right? So basically they will tell up to certain package is received. But because this 6 is not received successfully by the receiver, although the frame 7, 8 are received, but the receiver will not send out acknowledgement for these two packages, because these two packages are considered as out of order package. What they do is they will buffer these two packages in that receiver window, and then wait until this frame 6 receive. For example, they will continue send the the frame 6 again. This time, if successfully they receive that, then the frame 8 will send out the acknowledgement. We'll say it's a ACK 8. Okay, I hope this is clear. So that is why after doing that, you remember your good. Remember we said, right? You can using this acknowledgement, which also called sequence number, to acknowledgement to update your LFR, right? This because now you got the number to sequence number to acknowledgement is 8. Then now you can using 8 to update the original LF R value, which is 5. So basically originally your LFR is equal to 5, because before you sending this acknowledgement 8, your sequence number to acknowledgement is 5. The original this is 5, but now you receive this is 8, so you update with 8. Then after that, you can continue to update your LAF by calculating LFR plus RWS. If RWS is 4, then LAF will be equal to 12. I hope this is clear. Okay, so after that, basically, and here is some discussion. So this is good. Basically, compare with the stop and wait protocol. This one is the good thing is can using the bandwidth more effectively, but still always has some other situation potentially mitigate performance. For example, if the timeout occurs, basically, when the timeout occurs, you still not receive the certain packets or certain frame properly, then we will know the sender is not able to advance the windows, right? Because the overall the amount of data in transmission is decreases, and in other words, you will not no longer to occupying this pipe. Pipe is the bandwidth times the RTT, right? Bandwidth times delay. And then in other words, the longer, right, you will notice this package loss, the more severe and the ineffective of the usage of this pipe happens. Say one more time. So basically, the longer it takes to notice the packet loss, so the less occupants on the networking resources will be. In other words, the less effective of this protocol is. Okay, so in order to address that, we can change our acknowledgement protocol to negative acknowledgement or additional acknowledgement, or called duplicate acknowledgement, or we're using selective acknowledgement. Remember before what we call it cumulative acknowledgement, right? So that one we said is potentially has a disadvantage part. So instead of always need to wait until the last the appropriate package received to send out, I can using the other acknowledge protocol such as negative, additional or called duplicate, or selective. We will discuss that in today's class. Okay. So next one, we begin to just summarize what we have learned now. So we learned from the sender part and the receiver part to describing this sliding window protocol, right? For the sender part, we introduce three different terms: sending window size, which is the size allowed you to accept that package rather than sending the acknowledgement out. And the last acknowledgement received, which is here, basically the index associated here is the index or the sequence number of the frame which already sent out an acknowledgement. And also the last frame sent, which is LFS for short, which is here. Basically, already sent out the package but not received the acknowledgement yet. Okay, so basically when your new acknowledgement arrives, you need to shift this frame. Basically, your LAR will be increased, so you need to shift this overall window to the right, right? Because this one increase, this one value increase means this error will move to here, then the overall this center window will be moved to the right. And one thing you need to make sure to satisfy the LFS minus LAR should be less or equal to SWS. Okay, because the overall this capacity of the sender should be always large. Capacity of sender is represented by the sender window size always larger or equal to the number of package which are already sent but without receiving the acknowledgement yet. And we always will send the package, but until we find out the situation that when the timeout occurs, you still not receive the acknowledgement. If that is happen, let me say one more time. When the timeout occurs, you still not receive the package. If that is the case, happen means either this package or call frame is corrupt or acknowledgement corrupt or the frame delay. But no matter what happened, you need to resend this package or frame.